All right, everyone. I'm going to continue with the blockchain, the new blockchain series, and today we are going to start implementing our proto buffer types, right? So we already have our crypto keys coded in, which is very important because we need to sign blocks and all that stuff, sign transactions. So I thought it was a very good starting point. And of course, along the way, we are going to go back to things and make things better and try to change stuff up. Like I said, it's going to be an unscripted coding. So you have, I think that will give you the most value out of this. So the first thing we're going to do is basically, like I said, we're going to use protobuffer for all our encoding. So let's create a new folder. I'm going to call this proto. I'm going to call this proto. And inside of this proto folder, I'm going to make... that's a good question. Let's call this types for now. So everything involving protobuffer is going to be housed in that folder. So we can actually compile that. So we're going to call this, it's going to be types proto. Types proto, yes. And let me quickly open up some stuff from another project so I can see perfectly what we need to do here. It's going to be this one. Let's copy this here. Boom. Right? Because, hey, sometimes... So we're going to start with syntax proto 3. Protobuffer, for the people that don't know, protobuffer is a serialization protocol, which basically made by Google, I think. And you specify everything in a proto file, and then each language can compile that to a protobuffer format. We can do it in Golang, you can do it in JavaScript, in Python. It's a very adopted serialization protocol, right? And we are gonna do this in Go. And this is basically some boilerplate we need to do. So it's Go package. It's not gonna be micro. It's gonna be blocker, right? It's gonna be blocker proto. That's fine. And inside this file, we can start coding in our types, right? So we're gonna say, if you want to make a type, you're gonna call this a message. And in our case, we're gonna make some stuff. So the first thing we're gonna have is a block. It's gonna be a block. We're also gonna have a message, a header, and I'm gonna explain in a moment what this all is. We're gonna make a header here, and we're also gonna make, and it could be that we're gonna factor them out, right? So we're gonna start in the same file to make it easy. A message transaction. Just like that. Let's do it like this. Right. So basically in a blockchain, we have blocks, and a block consists out of a header and some other files, a header and transactions. You will see in a moment. And the reason why we have a header in a block is because sometimes we don't want to send everything over to nodes. Sometimes we only want to send headers for easy, for basically a simple verification. And we also do not want to hash. If you want to hash a block, we most of the time do not want to hash the complete block. We only want to hash the header. That's why they split it out, right? It's a very common structure. It's used in Bitcoin. It's used in a lot of other blockchain protocols. So we're going to have this block here. And let me quickly think. We're going to have... repeated. If you want to do a slice or an array, we're going to say repeated, and that's going to be repeated transaction. But we're also going to need the header itself. So we're going to specify the header here, which is going to be a header. That's going to be 1, and this is going to be 2. That's how we need to specify protobuffer. And I'm not going to cover how to install it. It's very simple. Just follow, and I'm going to make a nice README file. And if you are not already have access to my private repositories, send me a DM on Patreon or on Discord, and I will give you access, so you will have access to this code. And it's going to be more easy. Repeated. What's going on? I'm making these typos here. Repeated, just like that. It's going to be repeated transactions. Going to be transactions, just like that. So a block is going to consist out of a header, and it's going to consist out of transactions. And we're going to add more stuff later on, but hey, let's keep things simple and build upon that. It's very important. Don't try to do things all at once. It's going to shoot you in the foot. Delicious coffee. it's very important that these things follow up each other, and you will see, right? I can explain the complete protobuffer format, but like I said, it doesn't really matter. It will be clear by just using it, right? Cool. Then we're gonna have a message header. So what do we need in our header, our block header? We're gonna have an int32. It's gonna be a version. It's gonna be 1. And what is a version? The version is basically the version of the block, right? The version of our serialization protocol, because it could be that we have some fields right now, but later on that we have more fields, and we can basically, people that are reading, that are receiving blocks, they can check the header, they can check the version, and if the version does not match, they can say, yo, we are not compatible with each other, and then they can just find another node that has a correct version or something like that, right? It's basically to communicate the version of the structure of our blocks, a very important one. Basically very important for backwards compatibility and all that stuff, right? So we're gonna have a version. Normally in Bitcoin and all that stuff, you don't have a height. Well, you have a height, but the height is not embedded in the header. Nodes are keeping track of that variable, but we are going to keep track of the height inside of the header itself, because I think it's nice to have. So we're going to say the height is going to be 2. And the height of the block is basically, if you have 10 blocks, you will have a height of 10. It's basically an ID, let's say, but it's the height. They call it the height of the block or the index of the block, right? We're also gonna have a version, we're gonna have a height, we're gonna have a previous hash, which is gonna be bytes. The previous hash, and the previous hash is basically the previous hash of the block, of the previous block. That's why we use a chain, because we're gonna have these hashes and we're gonna link them together. That's basically the core semantic of a blockchain. Let me quickly check my recording here. Yeah, it's all fine, it's all fine. The previous hash, we're also gonna have the root hash, and that's going to be the root of the Merkle tree of our transactions. It's going to be 4. It's going to be it's actually the Merkle tree, Merkle root of the X. Right. Version height. We're going to have a timestamp. It's going to be an int64. Timestamp is going to be the timestamp of when the block is created. And it could be that we're missing stuff, but we will add stuff along the way if we miss something. Do we need something more in this block? Probably we need a signature and all that stuff. That's for later on. All right, so this is that. The next thing we're going to do is open up. We need a way to compile this, right? So we're going to add something like in our make file, we're going to add proto. And what I'm going to do is I'm going to copy something over, because, like I said, I do not know all these things at the top of my head. And this code will be available on GitHub. So give me a message so I can add you. So I'm going to copy, actually, the whole shebang here, to be honest. Boom. This is coming from another project, not the same. It's coming from a different project where I'm also using protobuffers. So this is going to be types. Actually, what we could do an asterisk. So we're going to compile everything into the proto folder, right? Everything that's in this proto folder is going to be compiled. That's fine. Let's see if I can actually make this. Make proto. All right, it's basically working, but I think we're going to have some problems. Let me open up this file. You see, it's going to be the github.com Google protobuff proto. So what I'm going to do is I'm going to go get this. Go get github.com golang protobuff proto. Boom. And it's working. That's fine. You see, now it's good. And if you open up this PB thingy, you see that it's basically a generated file from Go, and you don't need to worry about it. It's just protobuffer shenanigans. All good. All good, all good, all good. So that's that. Let's close this up. We have our proto file here. It's fine. So the next thing I'm going to do is create a new folder. And we could call this core or something like that, but I'm going to call this types. Types go. Types folder, actually. What's going on? I made a mistake here. Let's rename. Types. And in this types, we're going to make a file block.go. And we're also going to make a new file. It's going to be block test.go. And we're going to call this package types. And here's going to be the block itself, I guess. Package types here. Boom. Right. So in this types thingy, we're going to basically place block, transaction, all our type stuff where we're going to write our functions that basically going to do some helper shenanigans for these proto files. What you also could do is basically do some stuff so you can attach these functions directly on your proto buffer types, but I'm not a big fan of that, so we're going to do things a little bit differently. We're going to make this fast as fuck. So yeah, we're going to try to do not as much as abstractions. Oh man, I need this coffee. Okay, cool. So what I'm going to do is open up block here. And this is going to be block test on the other side, right? So what we're going to do is basically, what we could do is, yeah, I have an idea. So let's make the first function for our block a very important one. I'm going to say hash block, right? So we're going to hash the block. We're going to give this a block here, which is going to be a proto block, right? It's the type that's being generated by the proto buffers, and we're going to return a slice of bytes. It's very important. Hash block is the hash of the block, what we're going to do. So it's importing everything. That's fine. So if you want to hash a block, we're not going to hash the block itself. We're going to hash the header, right? That's what we're going to do. So if we open up this PB here, proto, you see, we're not going to hash the transactions. We're only going to hash the header. That's what we're going to hash, right? Because that's important, because it's also going to include the pref hash, the root hash of the transaction, so that's fine. And all that stuff. So, and the timestamp, so we are going to be pretty sure about this stuff. So what we're going to do is we're going to say bytes error is going to be, let's marshal this to bytes first. So we're going to say pb. Actually, I need to import this stuff like this. We're going to say pb is going to be GitHub. It's not going to import it automatically. That's the problem. GitHub.com, Google, Golang. Proto buffer, not quite sure if this is the correct thing. Proto buffer. Let me open up pb here real quick. Let me do this. Paste it in here. Call this pb so it's not conflicting with our proto package. Delete this. And then we're going to say pb marshal block. Right, and if there is an error, in this case, I'm just gonna panic out here. So I'm gonna say panic R, and then we have the bytes, right? We have the bytes of the block, and we're gonna hash that. We're gonna hash that with a SHA-1. I'm gonna make a comment here, hash block, hashes. Wait, I'm gonna say hash block creates a SHA. 256 of the header, right? I'm gonna say returns, actually, it's maybe better. Returns a SHA 256 of the header, right? You could do a double SHA 256 like in Bitcoin. What they do is they basically make a double SHA, double hash the bytes of the header, but hey, I don't think it's needed, but you could do it. It doesn't matter. Maybe we change it. We will see. It doesn't actually matter in our case. So we're going to say that the hash is going to be SHA 256. And we're going to take a sum, I think. Sum 256 here. And we're going to hash the bytes here, right? And then we're going to return. We cannot return the hash because this sum 256 will return an array instead of a slice, right? But that's no problem. You can convert this to a slice by doing this colon here, and it's all gonna be good. So if we open up our test here, block test, like this, we're gonna say func test hash block t testing.t, and what we're gonna do here is import. We're gonna install a package. Let me quickly see if I'm not coding in my screen. No, it isn't. So I'm gonna do is go get github.com. We already have that, this stretcher, right? This testify thing. That's fine. So what we could do is before we do this, we could make a util package And we could create a random. That's what I'm always doing, a random. And the reason for that is because I want to have some, we want to create random blocks, and that's going to be interesting for testing purposes. Package util, and we're going to say func random block, and that's going to return a proto block. What's going on here? I'm going to return a proto block here. Let's create the header first. So we're going to say that the header is going to be a proto header. Let me open up the proto file here so I know what's going on. Okay, so a version. You're going to say the version is not going to be that random. You're going to say version 1. The height is going to be a rand int n 0 between, I don't know, 1000 or something. And we need to convert that to an int 32 because that's going to return an int, I guess. Int 32 of this. Can it be 0? I think I'm gonna say +1. So we are 100% sure it's not going to be 0 here. Maybe it can. It doesn't matter. Okay, so the pref hash. We need another function for that. We're going to say func random hash. It's going to return some bytes. And we're going to say that the hash is going to be make me a slice of bytes 32, right? Because the hash is going to be 32, so we're going to pre-allocate a slice of 32 bytes, and then we're going to say a rand. That's going to be crypto. It's going to be C rand actually. Let's call this rand C. Crypto rand. Rand, wait. IO read full first. Rand C. Reader. Hash. What's going on here? People are messaging me, eh? So we're going to read full random bytes into this hash, and then we're going to return it. Return the hash. In this case, we can actually return, we're going to say here random hash here. That's fine. Then we're going to have the root hash, which is going to be the same thing. We're going to make a random hash just like that. What do we need? Again, a timestamp. It's going to be time now Unix nano. Just like that. And I think it's fine. So we have a header. So for the transactions, we don't have that yet, so we're not gonna do this. So we're gonna return just a block. We're gonna do the transactions later on. So we're gonna return the pointer to a proto block. We're gonna say that the header is gonna be the random header we just created, and the transactions we're gonna call that a day. We're not gonna do that. So we have a random block right now. So if we open up our block test, then we could say test hash block. So we're going to say that the block is going to be a random, a util actually, a random block, just like that. And then we're going to say assert equal the 32 block len block, no, hash block actually. Actually, we could do hash here. It's going to be hash block. We're going to give this the block len hash. That's going to be it. Of course, this is a problem. Let me open up our keys test real quick. Keys test, and then yoink this here, boom, paste it in here, delete that, and it's all going to be fine. So if we make test right now, boom, everything is passing, everything is good. Let me quickly remove my sweater. It's hot as fuck here. All right, already back. Look at this. Man, it's crazy. It's hot. Hot and expensive because energy prices. All right. So, test hash block. That's fine. Okay, the next thing we're going to do in our block thingy is And of course, we have this thingy here, and I think it's because we are using a deprecated package of the protobuff. But don't worry about that for now. Don't worry about it at all. Hash block. The next thing we're going to do is a very important function. We're going to say sign block. Because the blocks need to be signed, and you will see this coming together later on. So basically, each time a validator commits a block, he needs to sign that block. It's very important. He needs to sign that block so everybody can validate it if he signed that block later on. So that's something for later. You will see. First things first. So we're going to say sign block, and we need to have, we're going to call this PK, which is going to be a crypto private key. Remember, that's basically from the first episode, or private key. We need that. And is going to use this crypto package. We don't want that. We want to have our crypto package. Just like that. That's fine. And we're also going to need a B, which is going to be a proto block. And it's going to return a crypto signature. And it's going to be a pointer here. Boom. Just like that. So what we're going to do is we're going to just return. And we're going to say PK sign. And we're going to sign the hash of the block. So we're going to say hash block of the block here, and that's going to be it. Easy. So if we open up our test, block test here, what we could do is we're going to say func test sign block t testing.t. First of all, we're going to say that the block is going to be a util random block. Then we're going to say that the priv key is going to be crypto generate priv key. That's all stuff that we already did before. Maybe we could do a pub key actually. A pub key is going to be the priv key dot public. All good. We all have that stuff. Let's make a var here. And encapsulate all these things, so it's going to be nice and tight. The next thing we're going to do is the signature here is going to be sign block with the priv key and the block, and then we're going to say assert equal t. It's going to be 64. And actually what we could do, it's fine. It's going to be 64, and it's going to be the length of the signature bytes. That's the first thing. And then we're going to say assert true. We're going to validate the signature. So we're going to say sig verify. We're going to verify with the public key that we have. And it's going to be the block, hash block, right? The hash of the block. Right. That's it. So if we want to, so basically we're going to sign a block. That basically means that we first going to give our private key, because we're going to sign with the private key. We're going to take the hash of the block, which is going to be a bytes. The hash of the block is going to be a slice of bytes, 32 bytes long. We're going to sign that bytes with the private key, which will return a signature, 64 bytes long. Then we're going to verify that signature. We're going to verify that signature by giving the public key and again the hash of that block, and that should match. That's what we're going to do. That's the game plan. So let's make test here real quick. Boom. And it's all working fine. So that's good. So what we could do, I'm going to show you something. For example, if in test hash block here, we could do something like this is the hash, right? So we could do an FMT. Let me microCD kicking in. We're going to say println, and we could do something like hex encode to string. And we're going to paste in the hash, right? And then if we make test here, you're going to see that it's printing out the hash of the block. This is the hash. Right? That's basically what we're going to use to retrieve. You could actually retrieve a block by his height, but you could also query a block by its hash on the chain. And that's basically that hash, if that makes sense. All right. Let's do this. Let me quickly think. Because I want to split these videos up into sections, right? Because it doesn't really make sense that I'm going to do some transaction stuff right now, because then we're going to stop and then it's for the next video. So I'm going to try to group things up episode by episode. Some episodes will be shorter and some episodes will be longer. I think we have a signed block, we have a hash block, that's fine. Maybe we could make some helper functions. Do we need new block? Maybe that's for later on when we have these transactions. So I'm going to quickly check for the proto thingies. So pretty important is I'm going to make a nice readme how to install protobuffer. Very important. Maybe I'm going to link another video so you can install protobuffers. If you don't have access to this repository, give me a DM. It's very important, so you can just copy paste the makefile stuff, so you don't need to hassle around with that. It doesn't really actually matter. It's just like, I don't know how to do that stuff. I just copy paste and it will just compile it for me. That's nice, because you can spend a lot of time trying to figuring out how to compile this stuff. So I did it once in my life, and I keep copy pasting my solution, so I don't need to figure it out all the time. In the next episode, we're going to start with transactions with the UTXO model. It's going to be a very important episode, a very important lesson, because UTXO model is could be some kind of complicated sometimes, but I'm going to explain that. We're going to code that in. We're going to make that in our protobuffer. Then we're going to add transactions to our blocks. So we are set up with the base primitives. And then we can start coding in our server using gRPC and start adding blocks to our blockchain. It's going to be amazing. All right, cool. I see you in the next episode.